If you cannot see the screen, maybe you can move to front. Do you need to move to front? Okay. First part for IB physics. Orders of magnitude. So you can see in physics, we discuss a lot of stuff, maybe up to a big universe, observable universe, or to a very tiny particle, electrons, right? Yeah. So in the exam, sometimes they ask you a question. Okay. Yeah. So ideally, you guys need to memorize this table, like roughly. For example, the maximum one, the smallest one. Okay, that's a magnitude. And here, the smaller one. And you read through here, order of magnitude, just about the power of 10. Okay. This one, just about 10 to the power of x. That's the idea. For example, what's the order of magnitude? Check. Okay, bye. Try the homework. Okay. 10 to the power 3. What's the order of magnitude? Right? Just 3. Easy? Because the order of magnitude, just the power of 10. Okay, that's called order of magnitude. 10 to the power 3. The order of magnitude, just 3. Easy? Yeah. Order of magnitude means power of 10. Or, for example, 9, 10 to the power 5. What's the power order of magnitude? Just 5. Okay. Yeah. Easy? Yeah. The order of magnitude, just power of 10. But sometimes in IB, they give you hard question. Like, how about 5? If they give you, maybe we need a new page, okay. Make a new page. We check order of magnitude on a new page. Order of magnitude. So when we learn this topic, you need to memorize 2 types, like the information in table, because sometimes in the IB exam, just one question, just 1 mark about this page. 1 mark about this page every year. 1 mark. Order of magnitude. Some calculation. This part you need to memorize. This part, just calculation. Let's check. This is number. If 10 to the power 3, just 3. 10 to the power 5, just 5. 10 to the power -2, just -2. Easy, huh? In IB, they ask you another question. What's the order of magnitude? How about this one? What's the order of magnitude?这里边谁姓蔡呀？我。哦，你姓蔡，哈哈，嗨。Okay. Hey, how about this question? What's the order of magnitude? 蔡。哦，你是叫Andrew. How about this one? Or if they give you another one, 3 times 10 to the power of 8, what's the order of magnitude? Tsai, answer the question. Oh, you guys 8. How about this one? You guys 8. The question is about mathematics. The question really like this, guys. If this one equals 10 to the power of x, what's x? What's x? Eh? This part not in pre-exam, but you learned log. To calculate the x, you need a log calculator. Log 6. Eh? Calculator. Hi, calculator. Calculator. Okay. Hey, what's the value if you log it? 8.78. Hey, 8.78. So the order of magnitude? 9. Right? You understand why 9? Because you rounded, because it's bigger than 0.5. How about the second one? Just 8, because it's 8.48. Oh, less than 8.5. So 8. Okay. Okay, more. Oh, for order of magnitude, normally we use whole number or the integer. But the idea here, if this part is smaller than some value, you don't need to round up. If this part too big, you round up. If we say here A times 10 to the power of n, the order of magnitude sometimes is n, sometimes is n plus 1. If A big, of course, this is called the standard form, scientific form. A always between 1 and 10. Do you remember standard form? If A big, n plus 1. A small, just n. Who knows the boundary? Like, what's the meaning of big? A bigger than what? You need to round up. A less than what? You round it. This idea, like mathematics, check 10 to the power 0.5 times 10 to the power of n. This case, we have n plus 0.5, right? Oh, you need to round up because n, for example, n 8.5, we round up. So, but if 10 to the power 0.4, you don't need to round up, right? Yeah. Okay. If it's a 10 to the power 0.4, here just n plus 0.4. The order of magnitude just equals n. But this one equals n plus 1. How about 10 to the power 0.6? Oh, it's of course, we round it up, right? We round up, So the idea, the boundary is here. What's this value? Calculator, what's this value? 3 point something. Because 10 to the power 0.5 means square root of 10 is bigger.
3.16.
Oh, 3.16. Okay, if less than 3.16, you don't need to round up. If it's bigger than 3.16, something we round up. 162?
Yeah.
Roughly. They don't give you a question just on the boundary. Okay, that's the idea. That's order of magnitude. 因为很多它是现手的Oh, that's the idea, round up. Or no round, just an order of magnitude. Okay? Idea behind it, some mathematics. Or you can say this part. So, do you understand the idea? Yeah, this part is 10 to the power 0.5. Okay? Or root 10. Root 10. That's
10 to the power 0.4.
Oh, 0.4, for example, here 8. Here 8. You just got 8.4, the power. You just say 8. The order of magnitude just 8. Because we always round it on. It's like this. You got 8.48. You don't need to round up. The order of magnitude just 8. Yeah, any number, any number. We discussed this part because in IB paper 1, you cannot use calculator. If you can use calculator, it doesn't matter. You just log it. Just log the value. Like here, we just log, we know the value. But IB paper 1, no calculator. Okay. IB paper 1 for physics, chemistry, biology, I think all no calculator. Okay. In the exam, no calculator. But at school, sometimes teachers say, okay, you can use calculator. Yeah, that's the idea. This part to order of magnitude. Okay. Oh, you guys good at Chinese.认识吗？数量级，就比如说我的体重跟他的体重不在一个数量级，就说明他可能就20-30 kg， 我是100-200 kg 这样。不在一个数量级，就的意思是有的人是 10 to the power 2， 有的人10 to the power 3，那就是不在一个数量级。我没有，换成 Newton 比较多。Okay.
所以 A 小于它等于说是 N 的。
哦 ，Yes, just N。好的，给个什么例子？哦，怎么用这个 ？OK。
老师，但是6大于是等于6，为什么是9？
哦，因为本来是 to the power 8呀，加1了就变成9了。OK, one more. 5 times 10 to the power 8, order of magnitude 9.
只要5大于那个3.16，所以这个加。
对。哎呦妈呀，就他一般不会这样考的，头疼。6 times 10 to the power 20. 21. If 3.1 times 10 to the power 20, just 20. Because the first number too small. 啊，大脑和手不受控制了。Okay, that's the order of magnitude. Livia, any question?
No.
Olivia.
欧它是 Livia。
Okay, Olivia.
这是我们学校的 Livia。
对。
Okay. 哦，那个吴语就是他呀，
啊，对，
吴语子。
啊，对，
无语子，
哎呀，你们这微信名字实在是
是
太难懂
学
了。
我，
这是我。
OK，那
为什么你那天问我开呢？我名字还不够清楚吗？
不，我只是群发。
伤心了。
对了，
哎，in year 11 you learn a lot of units, right? And in units we have SI unit, SI unit, not SI unit. For example, who can give me example not SI unit? Oh, gram. Okay, gram. SI unit.
Yeah, kilograms.
Oh, yes. In SI unit, we got two types. One, fundamental one, or you say basic. In this book, they say fundamental. Yes. The other one is the derived one. SI, fundamental SI. That's about units. Because in physics, we always have quantity and units. Fundamental units. Oh, of course, like the society decide which one is like fundamental. Fundamental, we got 7. You need to memorize 7 units. Tsai, which 7?
Kilograms.
Kilogram,
Meter.
meter, second,
Mole.
mole,
Kelvin.
Kelvin,
Ampere.
amp. Kelvin just K, temperature, K. This is about time. Yo, what's this one about?
Particles.
Yeah, amount of substance, number of particles. You can say number of particles. Okay. This one popular in chemistry. Particles. K, temperature. A, electrical current. We need one more. One more, not in syllabus. It's about the light. It's called a candle, but we don't need it. We don't need it. Candle. Candle. How to spell candle? I forgot because it's not in the syllabus. Because in many years ago, how we measure brightness of light, or we say, oh, this room like 2 candles, very bright. Some room just 1 candle. A long time ago, but now we have accurate value for candle. Long time ago, we don't have a lot of equipment. We just use how many candles to describe the lightness or like the brightness. Okay, that's a unit. Derived unit, derived SI unit. We got heaps of this. In year 11, you know a lot. For example, oh yeah, meter per second. That's for speed or velocity. Let's check derived unit. Fundamental easy, just those several. And all derived units can be expressed as the algebra way, like a fundamental unit. For example, this 6 okay, this 6 okay. Temperature is called Kelvin. We know now, 0 degrees Celsius equals this much K. Okay, this much K. Okay, move on. We check the derived unit. We need a new page for derived unit. derived SI unit. Tsai told us meter per second. Normally, we write meter as 91, okay, in SI unit. We don't write this slash. We don't write this line here. That's for velocity. Arola, number 2, another derived unit. A lot. You just think about a lot of stuff you learn.
Kilometer per hour.
Oh, hey. Kilometer per hour, not SI unit. Kilometer per hour, not SI unit. We're talking about SI unit. But it's good you gave this example. The second one, Owen.
Velocity per second.
Oh, you can say meter per second square. That's for acceleration. Yeah. And the third one, you have a lot of famous one. Newton kilogram meter per second. Kilogram meter per second. That's for momentum. Kilogram meter per second. You might learn this one. This is m times velocity. This is called 它知道 Chinese momentum. 算了，把 Chinese 写在这儿吧，考试一点用都没有啊。Okay. Oh, if you take a language English B, you can have a little dictionary with you for all the exams. If you ask some specialist to give you some certificate, you can make your exam half hour longer than other people. If a specialist prove your writing speed too slow. Yeah, I had some student from AIC. His eco exam half an hour longer than other people.
Well, sometimes they get a laptop.
Yeah, I know some students like write essay English exam, just use laptop, not pencil or pen.
Can we do that in
No, specialists need proof. Yeah. Tsai just told us this Newton is for force, but this Newton, 1 Newton, same as kg m as -2. Why? Because in year 11 you learned the formula, force equals ma. That's year 11. That's m, that's a, that's f. Okay. So that's like a derived unit. We have a lot. For example, Ryan, tell me, I'll just write the unit. You tell us what's the quantity. Okay. What's this? For energy. What's this? Yeah, for power. A lot SI unit. Okay. Why we need SI unit? Guys, why we need SI unit? Okay, why we need SI unit? SI unit is really for convenience. Why? Hello guys. If you have a very long formula, force equals A, B, C over E, a lot of stuff times together. All the variables got SI unit, right? You don't need to worry about the unit calculation. If you all use SI unit, the final answer should be in Newton. Okay? You don't need to worry about all the unit calculation. So if you all change to SI unit, in the calculation, only numbers. You don't need the unit. Okay. That's why we use SI unit. And the other idea, that's also the reason in the exam, you just say, for example, force equals MA, and you just substitute number into it. Hey, you just know it's Newton because this is in meter. Oh, sorry, this is in kg. This is in meter per second square. So the answer just Newton. That will be easier. If you don't use SI unit, you need to think about the conversion. It's annoying. Okay. The second idea why we check unit, there's a very important stuff called homogeneity. What's this?
They're all the same.
Yes. Yes. For example, a scientist tell you a formula. Okay, said force equals. Right? We make it annoying. Okay. Speed equals square root of T over L. T is tension, which means in Newton. L is the length, meter. Hey, a scientist tell you this formula. Oh, this is speed with speed. Of course, you don't have time to check if the experiment all correct, right? But at least you can check the unit. For example, on the left, the unit is meter per second. On the right, it's Newton, right? Newton is kg, meter per second square over m. Ayo. If you square root of it, you got the root kg. That's 91. The unit not the same, which means the formula is wrong. Okay. The formula is wrong, huh? That's the idea, homogeneity. Any correct formula, both sides, same unit. Okay. Well, check the other one, guys. V equals root T over L. T, this one is still speed. This is still tension. But this L is linear density. Lucas. 谁是 Lucas？ 谁是欧文呢？好的。Lucas, what's density? Density is kg per meter cubed. What's linear density? It's not in the syllabus. It's kg per meter. Like 1 meter cable, how many kg? Okay. Now check if this formula correct. Check if this formula correct. Now we try to fix it on the right hand side. Kg meter as -2. Your kg per meter. Simplified, what happened? Really algebra, really algebra. Kg cancelled. M square as -2. M as 91. Okay. Now, this formula, if you check units, we say it's correct. Okay. But we are not sure if it's really correct. but the first example is really wrong. The second one, high chance correct. Okay. If you really prove the formula correct, it's take more steps on. But at least the first check, pass the first test on the unit test. Okay, that's for SI units. Of course, in the exam, they always ask you, can you find the expression for fundamental units? Like here, Newton equals this. That's like the expression using basic units. So idea about units. So every time you learn a new topic, you will learn a lot of quantities, and you always need to check what's the unit. Okay. Yeah, it's units. For units, we have another type of idea. It's called for units, we have some idea here. What's this? Do you guys remember what's the meaning of here? Very good. IB gave you all the prefix. Other exam, like Cambridge, they don't give you that. You need to memorize. What's the meaning of this? Yes, something in front. Like a typical one. If you just use meters, we have a lot. Like if we just use meters, if we just use meters, you have km, dm, cm, mm, mu m, nm, pm. Mu m. This part. All the letter here in, there's a big M. There's this. Hi, what's the meaning of D? That means 10 to the power of 91. C, this 10 to the power of 92. Little m, mu 6.
Oh, 6.
It's called the micro. This one famous. Yes, it's called the nano. Like a nanotechnology. Little p. Yeah, that's about the that's about the Beijing stuff, right? PM 2.5. This is a pico. I think it's called pico, but you can check because my spelling probably wrong. You need to double check the spelling. Okay. 10 to the power 3. Yeah, they think about some other stuff. Big M. 10 to the power 6 mega. Yeah. G. Giga. T. Tera. Okay. For example, sometimes in the exam, they give you some MS. What's the meaning of that? Not a meter second. It means millisecond. Millisecond. Okay. Oh, very lucky. This part in IB formula. In IB formula.
Okay.
Yes. Yeah, you better memorize because the top part, a lot of computer idea here. Computer idea. Like TB, GB, MB. Do you know the difference between physics and computer science? This KB is not really 1,000. It's this much, right? Yeah. Not 1,000, but roughly. Okay. Yo, we finish units. We finish units. Okay. Move on. This part, of course, better memorize. Okay. Next part. We finish units. Oh, of course, you can go over here on derived units. Oh, prefix. Ooh. No, just for topic 1. For the standard level, higher level, all topic, common topic will be 8 topics. 如果你们能把题做完，就一堂课一个 topic。
只需8节课。
直接考试。有题给我直接考试。
Okay. In science exam or IB exam, sometimes they ask you common sense. That would be this table. Yeah, for example, what's 1 kg in real life? Could be 1 liter of water. Could be a big pack of sugar. Okay. 1 meter is around here. 1 meter. Oh, sorry, no, this one. That's a German stuff.
Person would be 50 kg.
Like, what's the meaning of kg? For example,
What's the meaning of it?
Yeah, 1 kg like a liter of water. But for a person, could be 60 kg. Could be 70 kg. 1 second, normally heartbeat 1 second. 1 second once. Okay. At home, everybody use electrical device. For example, which one need a large current? Do you know that at home? Oven. This is not oven, it's oven. If you check oven cable, it's a very thick cable. Because we need a large current, like 10 amps. But all other electronics, like you don't need this big current. Okay. 吹风机, okay, also big power, but the current not that big. You can check. For example, if the power like 1,000 watt, that's electricity. You might learn equals voltage times current. New Zealand voltage is around 220 or 240. So this current less than 5 amp. Okay. Yeah. Hey, hello guys. Room temperature 300 K. But if you just say 1 K, 1 K is around -272 degree. Yeah. Okay. That's around 0 degree. Degrees Celsius. In temperature, we have F on Fahrenheit. Okay. And 1 mole is around 6.202 times 10 to the power 23 particles. This number got a name.
Oh,
Yeah, Avogadro constant. Okay, very good. So that's like an idea. Yeah. In chemistry, you use a lot more. Okay. Atmosphere pressure, Pascal. Yeah, normally in the tail, do you know the pressure inside here?
How high is the pressure?
Normally they use 37 psi. Oh, okay. That's pressure. Oh, psi is pressure. You can search online. Should be several hundred K. Should be around 200, for example, this much K Pascal. Like around double the atmosphere pressure. Okay. Yeah, a lot of knowledge in real life about physics. Okay. Okay. My one quite close. Oh yeah. You say it's 260 around. Okay. Good. Thank you. In physics question or in some theory, we always ignore some stuff. That's only like this table very important in IB. Sometimes you just use it naturally. They didn't mention friction, the question, you just kind of ignore it. But some question, the idea very important. Friction, you cannot ignore the friction. Yeah, you can check this because when we learn other topics, sometimes we make the question easier with some assumption. For example, you might learn free fall. If free fall, we assume no air resistance. If there is air resistance, we have some terminal velocity. Yeah, like that one. Always assumption. Oh, this part is just mathematics. We move on. Okay. SF. Yo, finally, the very important part. Yes. This part important and annoying. But in pre-IB, you learned that, right?
No.
Oh, no, okay. For uncertainty. For error, we have two types of error. Random error and the systematic error. I'll show you what's the meaning of random error.
Caused by fluctuations in measurements centered around the true value.
Yes. Yeah. We have a lot like a random error. But normally I sketch a diagram for you. For example, this is the true value. But your measurement, you measure maybe 10 times. You have different values for measurement, okay? So there's some spread here. Not all just on the true value. This is about random error. This is about random error. Random error. Random error. You can reduce random error by calculating the average. Like here, repeating the readings can reduce random error. You can say multiple measurement. Calculate the average. Averaging the multiple measurements or reading on average the repeated reading you can reduce random error. This part is really important for IB, IA. Like if you write essay, you always need to discuss something about error. To reduce the random error, you can measure several times, calculate the average. Okay. Or another idea, you try to measure the period for one oscillation, but you measure the total time taken for 10 oscillations. Yeah, you measure the time taken for 10 oscillations and you divide by 10. Or you try to measure, how thick is one piece of paper? You measure 100 pieces of paper. So you average. That's a way to reduce the random error. Systematic error. What's zero error? What's zero error? You have a scale at home. You stand on, they give you 60 kg. You don't stand on, they still give you 1 kg. That's zero error. Okay? Oh, you're right. Doesn't mean no error. Zero error means the actual reading should be 0, but not. Like the scale, nothing on the top, 5 kg there. This is called zero error. Zero error doesn't mean no error, okay? For example, like zero error, like you try to measure how many kg of the apple on the scale. Nothing there. The reading is 0.5 kg, which means, for example, you buy some apple, 2 kg. You buy 2 kg apple, right? But this scale gave you 2.5 kg. You buy 3 kg apple, this scale give you 3.5 kg. Always same amount. That's why in this summary, they say the value you need to subtract from every reading.
So it's the same error for all the, because of the instrument.
Yes, yes. So zero error. Ryan asked a good question. Zero error means the actual answer should be 0, but you have value there. Okay, that's called a zero error. That's about the instrument. Okay. Calibrate is a kind of adjust or something. Okay, now, guys, check here on this diagram. This diagram popular in the exam. Why we have random error? The data points scatter around the line. That's why we have random error. Sometimes above, sometimes below. Okay? What's the meaning of systematic error? They are linear, but the idea like for some quantity they should proportional. But when you sketch straight line, you find it's not passing through 0, 0, not 0 here. Not pass through 0, 0. In this case, we have systematic error. Why? In this case, we say systematic error. I'll give you example here. Why the triangles show systematic error? The solid line means the accurate value. For quantity B, the measurement is here. For quantity B, for example, we can say this is distance. This is time taken. Speed, no change. Distance, just proportional to time taken, right? But now, why we have systematic error? For 2 hours, it should be 10 km, for example. But for the triangle part, they gave you 15 km. For 3 hours, it should be 15 km, but they give you more km. Okay, so which means the distance measured always larger than the correct one. The green one is the correct one. We just take one example here. The green one is the correct one. This is the true one. The green one is the correct one. But your measurement is 15. Overestimate. That's why we say systematic error. And you can say all data point, all overestimate. That's called systematic error. Random error, sometimes larger, sometimes smaller. I mean, the measurement sometimes larger than the true value, sometimes smaller than the true value. If you find average, it's quite accurate. But the systematic error, you find average still larger. Because the rating always larger than the original one. Your average is still larger than the true value. That's why the triangle part we say systematic error. Analyzing errors, very important in IB writing, like essay on. IB, IA is 20 or 24% for final result. So IA is really important. Okay. Math, same. You need to write math essay, 20% to the final exam. If you got a good result in IA, your final exam, not that stressful. Okay. But every year in ASA, some student IA just half. 20 marks just got 10, or maybe 6 on 7. 100%, you lost like 15% already. Okay, so IA really important. For Manchurian students, they don't have exam. Due to the virus, there's no IB exam. So they just use school result and IA gave you final result.
I think that would be like easier than no IB.
Yeah, because this year no exam. Every student just throw away the books and then 解放了。然后就开始玩了，到处跑 ，OK， 然后就 lock down 了 ，OK。Why we discuss this much? Because in IA you always need to discuss this one, okay? For this diagram, we need to make it more clear. Could be, hello guys. Case 1. Quantity A overestimate. Overestimate means your measurement larger than the actual value. Could be this or case 2. quantity B underestimate. Tsai explain. I just explained A overestimate. Why? Because for each reading of B, your reading is larger than this. That's why we say overestimate. But why the other case? Why could be B underestimate? Yes, for example, if A is accurate, or if A accurate, B should be here. That's the correct value, right? But your one is this. Because your one is the triangle one. That's why B could be underestimated.
So is this for the systematic error?
Yes, we are discussing the systematic error here. We are discussing this case. This case, like, oh, hello guys, normally two variable proportional, you can sketch a line pass through 0, right? Yeah, that's the correct one. But when you try IA, when you try experiment, you find your data like this. That's your data. Your data is here. Now, it's a good idea, a good case. Why? You can discuss, right? You can discuss and show you critical thinking. For the green one, this is A, this is B. You can discuss. Probably the reason A overestimate or B underestimate. Two possible cases. Okay. Like for example, A is the period of something, time. Well, that means maybe your reaction time or something. You start the timer, but you stop too late, so you got a larger time taken. That's overestimate. Okay. That's good. In IB, IA, if you got some mistake, you can discuss. We don't need a perfect answer. Okay. You really need to think about back home why we say overestimate. Overestimate means the measurement larger than the actual one. Underestimate the measurement smaller than the actual one, the correct one. Okay. Okay. Lucas, any question?
No.
What you're asking? No question? Okay. Yeah, we discussed a lot this just for your IA on. And in the exam, they gave you this part. That's why in our booklet, we have some topic called, some question called data analysis. Data analysis. Yeah, for example, you can have a look. There should be some data analysis somewhere. Like here, a whole question just about based on the curve or based on number, ask you answer the question. Like here, this one. Okay, I missed some pages. Too many pages here, but some question repeated, so not that many. Okay. 没有，你如果假期刷题，你会开学之后会非常高兴的。真的。If you try a lot of practice after holidays finish, you feel, oh, I feel so good. But if you play too much during holiday, after holiday stop, school start, you feel, oh, so worried. Some question with answers. Okay. Okay. If the question no answer, we check together. I'll upload more answers. Okay. Next part. Accuracy and precision. Accuracy, precision. Some IB book use this idea. Some IB book use this idea. Normally, I don't use this. Like here. Remember this case? Some IB book use this one. Normally, I don't use this. Heavy. 哎，数学几点上课？
数学4点钟上课，
这是数学的小朋友啊。
5点半下课。
你上数学吗？
对，14点。
啊，对，是。
你要去海南我们。哦，牛逼，不会逼。
哦，原来你数学还有，
还有人不选
你这惊
AI
讶的
吗？
表情，你这这么惊讶干嘛？
啊，不会吧？真的有人选 AI 吗？
真的有人不选
真
AI 吗？
是没有选 AI 的，
在这个房间里，大家都是喜欢 AI high 的。
还是选 AI，还是选 A 3？
那你是比较幸运的啊。OK，
还有人选 AI 3吗？
很多啊，我们班全都是什么 Jason
啊，那 AI 3没关系。
AI standard
千万别选 AI standard，
A，
选完 AI standard 的很多专业都报不了了。
但他们不管，就
要选 AA standard。
可是那些韩国人什么100分的卷子拿什么10分、20分，
开心的要死。
然后还在那儿叫。
好多人都选 AI standard。
哦，那这种就一定要选 AI standard。
不是吧？
除了无色比考的特别好，
无所谓这个。
对，然后我也是刷版的。
OK，
哦，我都没跟 Ryan 说。
还有他
OK
你选他 history 还有吗？我傻了。
真的，明年 history 还肯定好玩，相信我。Kevin 也是，还有 Eric。
哦，叶晨，我还是3的。
叶晨这名字好好听啊，好像有个小说叫叶晨。
叶晨这个名字好好听啊！
回去告诉张哥，
那我现在明天就让包客来了。
明天他就来，
明
天就来上课。
哎，these 4 cases. These 4 cases. How we use words to describe these 4 cases?
哇哦，高能量。整个课后都在。
哦，可以回去下回去。如果没有，
OK，
网页都是网页。我这下
什么？他在用电脑干什么呢？不会是干一些奇怪的事儿吧？
看视频。
对，奇怪。
OK. Right? We use words to describe these cases. I prefer this. This is the true value. I prefer this case. True value.
哦，这是3D，是2D 的糖是吧？
This is about the target.
那是2D，是1D。
哦，这就可以。
This is about the number line. I prefer the number line.
这是卖保险。
他们是一个东西，一个是服饰，一个是。
Probably, yeah, you can try that way idea. Now we are discussing something called procession and accuracy. Eh?
这是谁呀？
Ryan 吗？我记得是 Ryan
，Ryan
一个女生的声音啊。
What the fuck？ 为什么会？
味道不对。
OK.
这是什么事情？
Oh, we need to describe the idea. These 2 cases, random error smaller. Why? Because the separation between measurement is smaller. Or you can say the spread is smaller. Random error smaller. Random error small, we have a word called precise or high precision. These two are random error small.
よし。
Okay.
这怎么这课一下太这个出来了？
Oh, these two cases, the random error large. Large random error. If large random error, we say low precision. But low precision, we say imprecise. Yes. Oh, that's about procession, huh? The other one. No systematic error. No systematic error. Because the average is true value, no systematic error. But this one, even your average is away from true value. So this one, systematic error.
So the random error is the difference, the gap.
Yeah, the separation between readings. The spread of readings. This one, we have a systematic error. From my diagram, all reading like overestimate. All reading overestimate. If no systematic error, we have a word. Accurate.
哦，游戏。还是
这日语不错呀。
必修会两个都说出来了。
我是日语厉害的。
真的。
也
日语
Whatever you gotta say,
然后日语 7，
然后中文是什么？
中文不选，
我英语也是，我英语也行。
哇，还有俄语是吗？
我英语是挺好，英语是。
那你是English
A 3
这说明欧文这个动画片看的很多。
啊，对。
日语好的话。
对，
日语好的都画。
这个动画
就学了那几
脑子大。
我不知道你在讲什么。
哎，
就学了那
看动画，看这个。
No systematic error is called accurate. If there is systematic error, what's the name? How we describe here? Inaccurate. Inaccurate. Okay? Accurate. Accurate, inaccurate. Okay. Oh, in some IB textbook, they use this side, the diagram. You can say the first one, inaccurate. Because all reading away from the center to one side. But it's quite precise. This one, accurate, but not very precise. This one, you accurate and precise. This one, inaccurate, imprecise. Okay. The theory behind it in mathematics, higher level. Okay. It's high. Any question?
No.
太
可它的名字太长了，我念起来有点困难。
菜
Okay. Yeah, that's the idea. That's the idea about the errors. When you write physics or science IA, you always need to discuss. You always need to discuss this. And how you improve.
啥叫 sources of error？
Like where the errors are. 就是它 errors 哪里来的？
Why your measurement got errors? For example, the equipment is so bad, so you have a systematic error.
哦，我手抖了。
手抖不一定。
写作时间没带脑。
早上睡觉了。
那这种要写到 IB 里面，恐怕就要扣分的。
你写，我在写这个 I 的事情。
IB spelling mistake 要不扣分。
spelling mistake。哎呀，
会扣分的吧？
哎呀，
这个
不会吧？这有人读。
Are you not gonna use family before you submit it?
depends on if the keyword is wrong. Maybe the sentence you have some word wrong, but the keyword is okay. Okay.
我给它划掉。
我比较好奇，那个 Chinese A 能不能用拼音写作？
可以。
我也想知道可以吗？
这个
对，可以。
我可以写拼音写好。
不是，如果你不会签字，你就必须得写拼音了，你还空在那儿啊。
你能那个
OK
一团乱写东西。
OK 啊 ，Next one. Some uncertainty really important. Check here. We got two types. We have two types. First one, analog. Second one, digital. That's all about the equipment. Analog, for example. This is called analog. Like a clock. Digital, like just this. Yes. They just give you the reading. It's called the digital. Because some ruler, we have a digital on. This part, again, in your IA. Because you always use equipment to measure stuff. You need to discuss the uncertainty for the equipment. For example, ruler. Ruler is an analog. They don't give you a reading like numbers. For a ruler, uncertainty is just half of the smallest division. Half of the smallest division. Right. For example, here, 0, 1, 2, that's a millimeter. At least you know it's more than half or less than half, okay? So half will be the uncertainty. For the equipment, uncertainty for the equipment or for the instrument. If you really use ruler to measure stuff, for example, you measure a pencil. You measure a pencil. This pencil reading uncertainty is not half. Check on, the ruler is 0.5 millimeter, right? But this reading, you have 1 millimeter uncertainty. Why? Why? Because this side, 0.5 error. This side, 0.5. You cannot really make it really just start from 0. Okay, that's why for the reading you have 1 millimeter.
If the ruler, like the zero starts on the end,
Oh, you still, for example, are you sure your eyes really make it here accurate? Maybe not. No. Wait. It's understandable, like making mistake. Oh. What I mean is here, you measure the both sides. This side you got 0.5 millimeter. This side you got 0.5 plus minus. Yes, you're right. Yeah. Because this side is not very accurate. This side not very accurate. You use this side minus this side, so it's not more inaccurate. 对啊。So for this reading, is plus minus 1 millimeter. Digital easier, huh? Digital just always give you the reading, okay? For example, if they give you 21.56 cm per millimeter, you can say plus minus 0.01 meter, okay? Again, very, very important. If you measure several times, we use the average, right? In the average, for example, they give you several reading here. This is about time taken. This guy probably used digital one. For each reading is plus minus 0.01, okay? For each reading. But in this case, you measure 5 times, you find average, right? The answer is not plus minus 0.01. We don't use this rule now. We use the other rule. After you calculate the average, you check something called the deviation. Oh, you know standard deviation? Very good. This uncertainty equivalent to standard deviation. For example, here. This number, cannot. Hello? This part, hi. This part, the spread really small. That means standard deviation is small, right? Standard deviation is small, means uncertainty is small. What happened? Thank you. No, the idea in physics, uncertainty, same as standard deviation, equivalent.
你再讲一遍没？从完成。
就是你这些results 的一个，它的差距越小，那它的 standard deviation 就越小，那它的 uncertainty 就越小，因为你很确定就是 accurate 的。
OK。
uncertainty 就是不确定。就你它差距越大，那你越不确定。
So for this uncertainty calculation, you can use standard deviation, or you just use deviation. Check out. They use the largest deviation. Largest deviation. Deviation. We have several readings. That's the reading. And we know average. Average, we use a bar here, 1.98. Now, what's the deviation? 0.03. Just the difference between the reading and the average. Aurora, what's the next one? 0.1, that's difference on 0.1016, right? The difference between here and each here. Yes. This one, 0.01. This one, 0.18. We are doing deviation now on deviation. 中文是偏差。哟，你湖北的吗？湖南的？那是怎么回事？会有这种口音出现 ？Deviation like a measurement minus x bar from the center. X bar like the center. For example, you guys learn standard deviation, right? Next step, you need to square all the values. That's standard deviation. But in physics, we don't square. We just make a positive.
So uncertainty is also the same as deviation.
Yes, the largest deviation. Check here. The largest value is as the uncertainty. For example, the largest one is 0. 是用2.01减去1.9吧？
The difference between the average and the reading.
Right, you got here. You got several reading, and you calculate average. This is average, right? This is separation 0.03. You always minus the average. Oh, this is deviation. This part called the deviation. Deviation just the value,偏差 away from the mean. But how we use deviation to calculate the uncertainty? Yes. That's why our reading, we choose this one, the maximum one, 1.98 plus minus 0.18. The first number from average, the second number from the largest deviation. Okay?
So is this the uncertainty for the average?
Yes.
Okay.
Yes. Not for a single one. A single one is just plus minus 0.01. Again, in physics, Cambridge, NCE IB, any system, uncertainty, we have requirement. For final answer, you need 1 SF. Okay? That's the first requirement. The second requirement, this one, same number of DP. This one, same number of DP. You run uncertainty first, and then run the previous part. 1 DP, right? 2.0.
So same number of DP for the uncertainty and the average value.
Yes. For example, if we have another average, 42.645 plus minus 0.059 meter per second. Okay, we run the second part first to 1 SF. But the previous one, same number of DP. 2了。You run the first one, step 1, step 2. Okay. All we discuss here, you need to use it in IA. School normally give you practice IA before the big one. It's annoying. I'll give you another one. We show step by step. Okay, you have a measurement. You have a measurement. We just make three 2.01, 1.99, 1. Maybe give you 4, 1.98, 1.5. Hey, we got the measurements here. You measure the same thing. You got 4 readings. You measure 4 times. Olivia, what's the first step?
You find the deviation.
Step 1, remove outlier first. This one, yeah, this one too much away from the other 3. So we remove it. Step 2, we calculate the average. Divided by 3. Okay? You really do this one in IA. No? So, what's the answer? Guys, calculator. Not tidy. 心算就没必要了吧 Okay.
1.22, 1.99.
No, we need more SF.
1.99333333.
Okay. That's average. Next step. We find the deviation. But step 3, we got 2 ways, both acceptable. The most easy way, acceptable one. Do you know we use standard deviation to measure the spread? Standard deviation? Do you know we also use range to measure the spread? Do you know range just maximum minus minimum? Okay. So standard deviation or range, the equivalent. This is measure spread. So the most easy one, you just use maximum minus minimum divided by 2. Acceptable. Or largest deviation. Both acceptable. This is the uncertainty calculation, like uncertainty equals. For example, we say, this is T, this is T, you got this as 4T, and this will be T average. This one will be the uncertainty in T. We use a triangle, delta. 哎，对，中文叫 delta.
Really?
B square minus 4AC. 你是东北的还是河南的？你山东的？山东哪里啊？哎，青岛小哥。是什么黄渤？黄渤
还在青岛开。
不是山东济南，中国青岛。
对，我认识好多青岛人，好多青岛人。还有人要请我回国吃河豚，去海洋大学里边没敢啊。
青岛大我去青岛
害怕呀，虽然是青岛海洋大学监制的，但是我也害怕呀。
青岛海洋大学监制的河豚。
对啊，他就他给负责处理毒，负责处理毒，保证没毒。河豚不是吃完就危险吗？
没有，
真的危险。
日本不就有吗？
是每年都有。OK。Let's check the question. For method 1, we use maximum minus minimum. The other one already removed. So the answer is 0.03 divided by 2, right? For the deviation, the working pretty long. You need to use this one minus the average. You use this one minus the average. In IB book, doesn't matter if you got negative, you just make it positive. In IB book, you can try this way. In the exam or in IA, you can try the easy way. I think the previous one, the first one easier. This is maximum minus minimum divided by 2. This one give you 0.015.
Because the deviation is the same as the range.
Equivalent. Maybe the value different, but equivalent. Same idea. This one, what we have here? 7, 0. Hey, what's this one, guys? Calculator. Guys, use calculator. We need the value for the deviation. Calculator.
0.01663.
Like this. Okay. The second one just 0.0033. Next one just 0.0133. Okay. Okay. The largest one we use will be this one. So for this one, that's why the answer 1.9933 plus minus 0.0167. That's for second method. The first method is 1.9933 plus minus 0.015, right? Okay, now we need a round. First step, round this one to 1 SF 2. This one, same. And this is 2dp, right? So 2dp. 2dp. We finished now. Okay. So you find the largest deviation or the half range. Half range is easier. Efficient. In the exam, you can do the first one. EIA. Okay. Okay. Oh, we finished a lot of stuff already. We focus on discussing like knowledge here. You guys can check this one back home. This is just about formula. Homework. This is homework 1. Other homework in Google Drive. Oh, I mean for them, Google Drive. For you, just here. Okay. Yeah. Oh no, you just try the first one. If you finish the first one, feel doing question pretty feeling good. Just try the next one. We got several worksheets here. Okay. Okay, this part we can check some IB questions next time. The day after tomorrow. Okay, see you guys.